So yeah, now we're looking at the equation of hyperbola centered at hk. Negative out in front. We'll switch that around to put the negative in between. We still got our x plus 1 and y minus 4. Hey, there we go. I see what you're saying now. A value. Let's kind of start calling some of these out. A value is? It is 5. Again, once you get the minus in between, the A comes first and the B comes last. That's kind of a nice rule. B is 2. Pythagorean theorem, let's see if we can do it in our head. 5 squared, 25. 2 squared, 4. 25 and 4, 29. Oh boy. Square root of 29. Hey, we got that one. Lastly, transverse axis. Horizontal or vertical here? Looks like it's going to be vertical. So we are using the right-hand side. Again, I'll give you a head start. So center, vertices, foci, there they are. Again, if you want to change that 4 plus square root of 29 to be a decimal, you could. Hopefully you were able to come up with those values. Let's talk about these asymptotes. So if we go back to it, we said it was a vertical transverse axis, so we were over here on the right-hand column, and the asymptotes are given as follows. Y minus k is equal to plus or minus a over b, x minus h. At first glance, what does this look like to you? Well, maybe not at first glance, but does it maybe look similar to something you've seen before? How about point slope form? Y minus y sub 1 is equal to mx minus x of 1. Remember working with that guy? So the reason they're using it here is because before, when we were centered at the origin, our y-intercept was 0. Okay, so we didn't have to go back and have to try that b value. We just knew that was going to be 0. So we could simply go y is equal to b over a times x, or y is equal to a over b times x, whatever. But unfortunately, now we're not centered at the origin, so now we do need to find that new b value. We need to find that y-intercept, okay? This form most definitely works. You can use this if you want to, but I just do y is equal to mx plus b. All right, you're able to use either one, okay? I don't think I'm going to show you both just for time's sake. Let's just do it with y equals mx plus b, and then you'll kind of see how it goes from there. Y is equal to mx plus b. And one more time, understand what we really need is that b value. I would like to know where it intercepts that y-axis. So slope, can we determine that? What is that ratio going to look like? Very good. Your slope is a over b. A over b is 5 over 2, so 5 over 2. We're still going to use that. But now I'd really like to have an x and a y value. Where do we know, or do we have a point that we know is going to be on this asymptote? The center. Yes. The asymptotes will always go through the center of the hyperbola. And the center we said was, well, let's look at it. Negative 1, 4. So my x value is negative 1. Y value is 4. I've got everything else plugged in. Now I can solve for the b value. So the b value for this one comes out to be 6. So as we rewrite that one, again, kind of all over the place, so bear with me. 5 halves, we're going to keep that, plus 6. There's our first asymptote. Actually, it came out to be 6.5, didn't it? My bad. 6.5. Really making a mess of things today. Everybody good with that? We need to do the same thing for when we do -5. 4 is equal to -5/2 x plus b. We get a b value here of being 1.5. So y is equal to -5/2x plus 1.5. All right. How complicated do we need to make our lives? Well, it depends on how they ask it. If they ask you to identify the asymptotes and actually write out the equation, unfortunately, you're going to have to do this mess. Okay? Let's say they don't ask for these and they just ask you to graph it. There's kind of a cheater's way around it. So -1, 4. -1, 1, 2, 3, 4. There's our center. Vertices, we're at -1, 9. -1, -1. There they are. And now the only thing that's really missing from the graph is just graphing the asymptotes, right? But here's the deal. We said the asymptote's got to go through what? The center point. So if we know where one of the points at, can't we just draw the slope in off of that point? So let's go ahead and do that. We know one of the slopes got to be 5/2. So from our center point, up 5/2. Notice it gets you right to that vertice. That's good. And then over 2. Down 5, left 2. The other slope was -5/2. So down 5, right 2. Up 5, left 2. There it is. So again, it depends on what they want. If they want you to graph it, you can actually use that, identify the center, graph your ratio, rise over run off of that. If they need the equation, then you're going to have to do this down here. Sound good? Last page. You're doing great. Similar to what we did with the equation, we do got to go from a general form to a standard form. So we should be able to move a little bit quicker today. X's together. Y's together. I'm going to move that 58 over, so add 58, so that -58 now becomes positive. We need to get the x squareds and the y squareds to have a coefficient of 1, so I'm going to factor out 3. Do you think we should factor out the negative or leave it in there? I would factor it out. And when you do so, that's going to change that to now be -8y. Plus blank, plus blank, plus blank, plus blank. There's our setup. Let's see if we can complete the square in our head. Half of 10 squared. Half of 8 squared. Very good. 25 and 16 over here. No. Nope. 3 times 25 will get us 75. Got to be careful. -7 times 16. -112. I might kind of combine steps here. This is going to factor to x plus 5, x plus 5. So x plus 5 quantity squared. This will factor down to y minus 4, y minus 4. Same thing as y minus 4 quantity squared. 58 plus 75 minus 112 is 21. That's convenient. 21, 21. Both 3 and 7 are factors of 21. So yeah, once you catch on to it, honestly, completing the square isn't too bad. I mean, if they give you good numbers, hopefully they give you even numbers, divide by 2, squared. You can kind of start doing some of that stuff in your head too. Okay, we could say this is a transverse axis being horizontal because it's x minus y. What's your a value going to be here? One more time, let's be sure on that. Square root of 7. Very good. Last one. Given a couple of criteria, now we want to come up with the equation, so let's see if we can do this. Vertices are here and here. Foci are there and there. Again, sketch is always helpful. You can literally start counting some units if you can sketch it. -9. And 1. Those are our vertices. Could we find the center point now? Yeah. Where's that going to be at? Yeah, it is going to be a -4. Our total distance between these 2 points is 10, so half that is 5. 5 units away from each of those is -4. So there's our center point. That's good. Foci, -17 and 9. So because the foci are there, this tells us that, well, we knew it was going to open up left to right because of the center point in the middle. Transverse axis, horizontal. H, K, A, B, and C values. What do you suppose your H value is? Or what's H comma K? -4, 0. Yep. So -4, 0, that's your center. We could write that if we wanted to. What's your A value? Huh?
81.
Ooh, no.
Oh, is it the?
Somebody say 9? Not 9.
25.
Keep guessing.
What?
You were close with 25. What did the A value represent again? Distance from what to what?
16.
Vertice to the center. So if our center's at -4 and one of these is at -9, what's that distance?
Oh my gosh.
5. There you go. C value, distance from the center. Yeah, so when you said 25, I think that's what you meant, right? We'll go with it. C, -4 to 17, 13 units. And the B value, we could do Pythagorean theorem. Oh my goodness, it just will not leave us, right? Silly Pythagorean theorem. Just won't go away. It won't. No wonder we spent so much time with it when we were younger, right? Anyways, there it is. I think we have everything. If we go back to our template for horizontal, horizontal was x minus h quantity squared minus y minus k quantity squared a squared b squared equals 1 x minus h, so plus 4 over 5 squared, which is going to be 5 squared. K value is 0, so if we wanted to, we could just go squared. Again, that, or probably the back of the book is going to give you this.